There are so many ways to make hitboxes, but if you want the most accurate without regards to performance optimizations, then using spatial queries is going to be the right move. Now, before we get started, I'm not saying that this method is unoptimized and super costly. Roblox is actually pretty efficient when it comes to using this, and I even use this in my own hitbox module. But enough of that, let's get into it. So about 4 years ago, Roblox made a pretty substantial upgrade to how they do their collision detection via spatial queries. I will link the full documentation in the description if you want to read into it. To sum it all up though, they ended up going from a 2-phase collision system, broad to narrow, to a 3-phase one, broad to mid to narrow, and in doing this, they greatly sped up their physics engine and in turn improved the performance of spatial queries. The main benefit to using spatial queries as opposed to using magnitude like I went over in the previous video is going to be accuracy. You see, when doing a spatial query, any point inside the region you provide will be considered a hit, which is probably what you expect when you make a hitbox. However, when using the magnitude method, your part's center must be inside the region. As you can see in this drawn example, the one on the left is considered a hit, whereas the one on the right is not. So there are a couple different kinds of spatial query methods you can use, so let's quickly go over each of them. First up is going to be get part bounds in box, which takes in 3 values. One being the position and rotational C-frame coordinate for where you want this box to be, the second being the size at which you want your query/hitbox to be, and the third being your overlap parameters in which to filter your results. This is probably going to be the only one you really use because of how easy it is to modify and change. Second is going to be get part bounds in radius, which also takes in 3 values, one being the position of your query, the second being the radius, and the third being the overlap parameters. This can actually be used as a substitute for doing magnitude checks if you want the accuracy of queries whilst maintaining that circular/spherical detection space. Third is going to be get part bounds in part. This one is actually quite different from the other two for a couple of reasons. First, and most obvious being, it only needs 2 parameters, one being the part and the other being your overlap parameters. The second, and most important part, being that it actually does hit detection a little differently. But to understand it, let's go back to the other two for a second. As stated directly in the documentation, using either the box and radius overlap queries, they will only check against the part bounding boxes. This can be visualized by adding a selection box to whatever part you're wanting to check against. You can begin to see why this could lead to some visual inaccuracies when using these. This, however, is where the third method shines. The get part bounds in part query does a full geometry collision check on other parts. This means if you want the most accurate hit detection using spatial queries, this will be the one you use. But do note that it does come at a slightly higher performance cost than the other two, and this is stated in the documentation, so don't come after me. For my example code, I will only be showing get part bounds in box. The reason being is it's still very accurate whilst also keeping the performance cost as low as possible, essentially creating a nice middle ground. Let's get started by setting up our module with our spawn function. We're going to be taking in one argument, which will be our hitbox data. But what is our hitbox data? This is going to be a custom type created at the very top of our module script consisting of 3 properties. Frame, which is C-frame, size, which is a vector 3, and params, which is our overlap parameters. We can then type check this argument to be our custom type, which means that anytime we go to add it in here, Roblox will help us with autofilling the correct arguments. We should also check if our hitbox data actually contains all the arguments that we want. If not, then we can safely return without breaking anything. Our next step is to actually call our create function, which takes in all 3 properties of our hitbox data. This gives us a list of all parts that we detected. This isn't very useful to us right now since we don't know which actually belong to a character and which are just random parts in our game. We can, however, solve this by creating our next function, which will filter out all the characters just from our list of parts. We should first make sure that our list is actually a list by asserting the type, similar to what we did with our spawn function. We should then check if our list actually contains anything. If it's completely empty, we can just return an empty table because obviously we didn't hit anything. We can then create a new table and begin our loop. We then make sure the part is actually a descendant of a model by using find first ancestor of class. If it finds a model, we move on to the next check. Otherwise, we use continue, which basically just skips to the next iteration of our loop. We then check if our found model contains a humanoid. If not, we continue, and if it has a humanoid, we also need to check if our enemy is alive. If they aren't, then we also continue. Our last check is finding out if we have already added the character into our list. The reason we do this is because we can hit multiple parts of the same character at the same time. So, to prevent adding duplicates, if we have already found the character from a part we checked previously, we obviously don't want to add them into our hit list again, because that'd be dumb. Then, if it doesn't find it already in the table, we can then just add it. And after our loop is over, we can return our list of found enemies. It's a very simple loop, but it does the job perfectly. Now, going back to our spawn function, we can then create a success variable to determine if we even hit anyone. The way we figure this out is checking if our enemies table has anything in it. If it does, then we successfully hit someone. Now, this isn't necessary, but I went ahead and created a visualization function which shows you exactly what the hitbox looks like. I find it very helpful for debugging. If you also want it, here's what it looks like. And after all is said and done, we can return whether it was a success and also return our enemies table. Here is an example script of how you can use this in game along with how you can set it up in the Explorer. If you found this helpful in some way or you want to see more content like this, I would appreciate you liking the video and maybe even consider subscribing. Anyways, I'll see you in the next one.